Hi, the lesson that we're talking about today is on bearings. It is an application for vectors. And so we're going to start by looking at the help sheet that's online. The definition of a bearing is the measuring of an acute angle that a path or line of sight makes with a fixed north-south line. So there's types of bearings are air, land, nautical. When we're measuring direction, we always start from the north, and since that's how we read the compass, so no matter which kind we're doing, we always kind of start with that north line. We use a compass rose to determine the angle. In other words, the angle that the path changes. So for instance, if we're doing air navigation, an angle measured clockwise from the north line. So we would start up here at north, and then we would have this angle that shifts the path over here to this line. And if we're doing nautical, then we tend to go from the north or the south line. So if we started at north and we pushed the angle around here, that would give us the measurement from the north line. If we were starting below the horizontal axis and we measured the path over to here, then we would be going from the south line to the east. Bearings to-do list or things to remember. Draw a picture of the situation. Draw a compass rose where you are finding the bearing. So if you have a problem where you change directions or change paths, then you want to draw that bearing there. And so you may have more than one compass rose on a problem. Use trig to calculate any missing information needed for the problem. Solve the problem. Give answers in correct units and in the correct form. Distance in nautical miles or bearings at 225 degrees. Give bearing answers in the correct form. So if we're talking air, your answer would be 225 degrees. But if you're talking nautical miles, then you'd be doing like something like north, 45 degrees east. Never round inside the work of the problem, only round the final answer. So you might need to store values and figure out some way to designate them on your paper. My students put quote marks around them so that they know if they have something stored. You can also store anything in all the letters A to Z on your calculator, so you can make those kind of stores helpful and beneficial by being able to assign it whatever letter that you would like. The easiest one to use obviously is xt theta. So to store an xt theta, you would have a value, press the store button, press xt theta, and then hit enter to execute it. It will just keep storing values over in the home screen, so that's what you do when you just kind of don't clear it, you just start over. You can also go up to retrieve a previous answer on your calculator. That's another way to avoid a rounding error because you really don't want to have to round, because every time you round, before you get to your final answer, you decrease your accuracy. So never round until you get to that final step. So you want to use those tools to help you do that along the way. All right, so the first one is this true bearing, and the true bearing is a compass heading from 120 degrees, and so basically what that means is from the north, it went around here to the path, and that is 120 degrees. And then it traveled down that path for 2 hours at 200 miles per hour, so that's a 400-mile distance from here to here. So that's an example of a true bearing. A compass bearing is navigation from the description of all the angles acute and measured from either the north or the south line. So John drove north 30 degrees west for 100 miles. So from the north to the west, he went 30 degrees this way, and so that's the path that he's traveling for 100 miles. Sometimes you have a change of bearing in the middle of a problem. So here's an example of that. So this first one starts right here, and it is an airplane that is flying 500 miles on a heading of 60 degrees. So remember, air starts at the north, and it goes 60 degrees this way. So now the plane is flying along this path. Then it changes direction again, so a new change of direction means a new compass rose right here, and it changes direction and flies for 200 miles, so that's this way, on a heading of 150 degrees. So the 150 degrees starts from the north and goes all the way down to here, and that's the new path of the plane. So could you find the distance between where the plane is now and where it started? Sure, you could draw that line in there, and since we don't have any right angles, you could use law of sines or law of cosines, or maybe there's some other vector work with angles that you could do that would help you figure that out. But that's everything that is on your bearings help sheet that you'll find on campus, or on Canvas, excuse me. Now we're going to work through the notes for day 2 on vectors and applications. So this first set, problem number 1, is talking about headings and bearings. And so the first one are bearing problems, because you can see it tells you from the north or the south and which direction you're going from there and what's the degree that that's changing, that path is changing. So I start at the north and I go to the west and I go 50 degrees. So we're talking about that little measurement right there. Here I'm going from the south, so I start at the bottom and then I'm going to the east, which is over here. So my line is pushed over here and that's where my 40 degrees is. On the next one, I'm going from the south to the west, so I'm going from the south to the west over here. So the path of the plane is right here and it's 30 degrees that it's pushed that path over from right there. On the last one on this row, we're going from north to east. So here's north, here's east, and we pushed over 20 degrees, so it went this way 20 degrees, and now I have a new path right there. The next set of problems are true headings. In other words, we're talking about maybe air miles right here. So we start up when you just see the 50 degrees. So we're starting at north and we're going clockwise 50 degrees. So we're talking about that change in path right there. The second one, we start from the north and we go 250 degrees clockwise. So starting here all the way around the path to there is 250 degrees, and that's where the new path is. So maybe the new path of the plane or something like that. This one is 310, so we go north and we go clockwise all the way around to 310 degrees. And finally, 130 degrees. So I start up here at north and I go 130 degrees this way, and that's the path that I'm on right now. On problem 2, a ship travels at a speed of 20 miles per hour for 3 hours on a compass heading of 200 degrees. It then changes direction and travels at a speed of 30 miles per hour for 2 hours on a heading of 330 degrees. Draw a diagram of this situation and find the angle between the two paths. So here is my diagram. So I started up here and I drew my compass rose because I was going to go on a compass heading of 200 degrees. So I went from here to here. And then I traveled that path at 20 miles an hour for 3 hours. And then I changed directions here by 330 degrees. So again, right here at the north, and I go all the way around here to 330 degrees. And that's where my path is right now, which traveled 60 miles per hour total. So I know that if this whole angle here is 200, here is 180 degrees, and I can take 200 minus 180 degrees and figure out that this little piece of this angle is 20 degrees. And the reason that is important is we have a theorem called alternate interior angles. So if this is 20 degrees, then this one's 20 degrees. And so I now know this little angle right here. Well, I also know that if I started here and went all the way around to here, and that was 330, I'm almost back to the beginning, which is 360. So if I take 360 minus 330, that leaves me with 30 degrees, which is what this angle right here has to be. So that tells me then if this little angle is 30 and this little angle is 20, 30 plus 20 is 50. So the angle between the paths is 50 degrees. Number 3, a surveyor gives the following description of a plot of land. From a granite post, proceed 195 feet east along Tasker Hill Road, then along a bearing of south 32 degrees east for 260 feet, then along a bearing of south 68 degrees west for 385 feet, then due west back to the point due south of the granite post, and then finally along a line back to the starting point. So we're going to draw the diagram of the plot of land showing all 5 angles and showing the distances. So here is the first one. And I plotted this out, so it kind of starts looking like a pentagon. So I wanted to refresh your memory about a couple of things. Remember that the number of degrees in a polygon is 180 times n minus 2. And then the degrees of a pentagon is 540 degrees. So when we're through, when we add up all 5 of these angles, it should add up to be 540 degrees. All right, so I calculated through each angle. I went ahead and labeled it so that I would have the calculation or be able to tell what I was calculating. And I know right off the bat A and E are 90 degrees, so I have 2 of the angles so far. Then to find B, I'm looking over here, and so I know that I made here's my compass rose, and I know I went south 32 degrees east, so that's 32 degrees right there. And then I know I went and plotted down this way for 260 feet. Then I went along a bearing of south 68 degrees west for 385 feet. Then due west again. Okay, so I know that if this is 32, then I know that when I add 90 to that 32, because there's 90 here and there's 32 here, that the angle from here to here is 122 degrees. For angle C, okay, so now I'm talking this angle right here, I know that 90 degrees minus 68 degrees is 22 degrees, right? So 90 degrees minus the 68 is 22. And then I know that 90 minus 32 is 58. And I know that 22 plus 58 is 80. So when I'm adding all of that up, it kind of helps me fill in some of these pieces right here. So angle C is right here to here, if you can tell. So that's 58 plus 22, which gives me my 80. And then I'm looking at D, so I know I have alternate interior angles here. So I know that's 58, and so if that's 90 and that's 58, then I know that that angle from here all the way around to here is 158 degrees. And so we've calculated all the others. So we know 2 of them are 90, 1 of them is 120. I have an 80 and a 158, and so if I add those up, I get 540 degrees. Problem 4, a plane flies for 3 hours at a speed of 200 miles per hour on a compass heading of 120 degrees, so we know we're going to go from the north clockwise, before it changes directions to avoid a storm. It flies for another 2 hours at 250 miles per hour on a heading of 20 degrees. Draw a diagram to represent the situation and then find the angle between the 2 flight paths. All right, so here is my first one. So it says that I flew at a compass heading of 120 degrees. So I started over here. Here's my compass rose. 120 degrees goes from here to here. So the path is flying this way. And it changes directions to avoid a storm. And it flies for another 2 hours at 250 miles per hour on a heading of 20 degrees. So the heading, remember, draw a new compass rose right here, and I'm going 20 degrees, and here's my new path. So what we need to do is find the angle between the paths. So when I'm trying to find that angle between the paths, I'm trying to find this piece right here. So I know this is 20, and I know because of alternate interior angles that this is 20. So then I can find this piece here at 90 degrees minus 30 degrees would be 60. So now if I take my 60 degrees plus 20 degrees more, I get 80 degrees. Okay guys, our last problem today, number 5, You have boarded a plane for your summer vacation. The pilot flies due east 140 miles, then turns to north 59 degrees east for another 120 miles before landing. For the trip home, you decide to purchase a non-stop ticket. What is the distance you will travel on your return trip home? So the first thing we're going to do is figure out a picture. So I know that he went due east for 140 miles and then he changed directions and he changed from the north 59 degrees to the east. So now we're traveling on this path. We get here and then we're going to turn around and go all the way back home. So that's what we're trying to find. So my return trip home. So if this is 59 degrees and this is 90 degrees, then I have this angle. I have this side and I have this side, and look at that. I have a side angle side situation, so I don't have to use vectors and remembering alternate interior angles to solve this. I can actually use law of cosines. So since we have this side angle side triangle, solve with law of cosines. And so the angle that we found here is the 159 that we're going to use because that's the one that's sandwiched between these two. So remember, this side squared plus this side squared minus 2 times this side times cosine of this angle. So when you write all of that out, it looks like that. So once you have it all laid in, then we know we're going to take the square root of both sides, and then we can crunch the numbers and we get this, and then we know that we would answer the problem by saying the distance of the return trip home is approximately 250.601 miles, because it did say to the nearest 3 decimal places. All right, so that takes care of some bearing examples to give you a few examples of different types of problems, and then you can work on your individual application of that in your problems. Thanks, guys.